So hello students, welcome to our video classes, and I am Anik Ghosh with you, and today we are going to learn the chapter of biology. So hello students, welcome back to our video classes, and I am Anik Ghosh with you, your biology teacher, and today we are going to start with the air around us. Okay, so this is a very interesting chapter, and I just want your entire attention in this chapter because you know what, today we are going to learn about something which is very much important. Because look, we know that there are so many things, there are so many gases, there are so many different types of particles, those are around us. Okay, and there is a thin layer over the atmosphere, over the earth, so earth ground level. Okay, right? So over the ground there is a thin layer of air. So what is that, what do we call it, and how does that thin layer of air works for us? What is the useful So hello everyone, welcome back to our video classes, and I'm Anik Ghosh, your biology teacher. And today we are going to learn the first. Hello students, welcome back to our video classes, and I am Anik Ghosh, your Hello students, welcome back to our video classes, and I am Anik Ghosh, your biology teacher, and today we are going to start the chapter air around us. Now, you know that the air is everywhere, right? Air is everywhere. Now, still we cannot see it, we cannot smell it, and we cannot see it, right? But the only thing that we can do is we can just feel it, right? So there are so many things that is happening around us. Like, do you know that there is a thin layer over the ground of earth? We call it atmosphere, and it is saving us from so many harmful rays like UV rays and different types of other rays like IR and different types of rays, cosmic rays. Those are coming from the sun. Okay, and it is saving us. It is like very much useful for us, because otherwise we could have get skin cancer and different types of skin diseases and whatnot. Okay, so for that reason we need to learn about this chapter so that we can get a proper idea that where are we getting the the molecules of oxygen to breathe, where are where does the carbon dioxide that we leave during our respirations, where does it go? So there are so many important things that we can learn from here. Okay, what do we call by pollution? Why are we calling that the air is getting polluted? So what do you mean by this pollution? So there are so many things that we that are needed to learn right now, because air is one of the most important things needed to live, right? Think about it. You can live without food, without water for 2 to 3 days, isn't it? But if the air is not pure, then it is very much difficult for you. It is going to be very much difficult for you to live for even a second, isn't it? So for that reason, this chapter is going to be very important for us. Okay, now I want your 100% attention, because you know what, today we are going to learn so many things. Those are very much, used to be very much useful for our everyday life. Okay, now first, today we are going to learn about the layers of atmosphere. So how the atmosphere, so I think I have told you, like, if this is the earth ground, okay, if this is where we are standing, then over our head, okay, up to 500 kilometers, okay, there is a layer which is called the atmosphere. And this atmosphere contains all the types of gases that we have ever heard about. Like, give me a moment. Yeah, like oxygen, like nitrogen, like carbon dioxide, and they are all there in a proper proportion. There is a particular definite proportion with which they are there, present there, right? And that is called atmosphere. And this atmosphere is providing us all the types of gases that we need to live. Or there are some different types of gases as well that we do not use to breathe or do not use in our everyday life. But yeah, there are so many gases in the atmosphere. Okay, and they have a particular proportion as well. We are going to learn all about it, and where do the gases live, and what is the concentration of gases in which portion of the atmosphere. We are going to learn about that in details. Okay, the second thing we are going to learn is properties of air. So as I told you, the air is all over us, right? But we cannot see it. We cannot smell it. We can only feel it. So what are the other properties of air? That is the thing we are going to learn in this video. Apart from that, the composition of air or uses of air. In crudely, we know that like 78% of the air is made up of nitrogen, isn't it? And about 21% is oxygen. So these two are the major constituents of the air, right? But there are some other gases as well inside the air. So we need to learn about them as well. What are the composition? What are the percentage of those gases? Like what are the percentage of noble gases? What is the percentage of carbon dioxide in the air? And how does it how does it work? How did like the balance in the air? We are taking up this oxygen every day, right? But still the oxygen percentage is a constant value. So how does we keep that balance? Everything we are going to learn in this chapter. Okay, and let me tell you, we have some very cool videos as well. We are going to start with the first video, but this is the introduction to this chapter. The envelope of air that surround the earth is known as atmosphere. As I told you, if this is our earth, there is a layer of the air particles, of the gaseous particles over the earth's sphere, right? So that is called the atmosphere. Okay, now this atmosphere is like they're saying that this atmosphere is essential for the life on the earth. There are so many reasons behind it. Okay, this atmosphere not only gives us oxygen, but it also helps us protects us from different types of radiations as well, as I told you earlier. Okay, aquatic animals use dissolved air in the water for respiration. You might be thinking, if I just take my head in to the water, okay, what would happen? Would I be able to breathe? I would never be able to breathe, isn't it? So that is the thing. So how do the fishes, or how do the aquatic animals, how do they breathe then, right? Isn't it a very valid question? So yeah, they breathe the air or the oxygen which is dissolved in the dissolved oxygen dissolved in the water. Look, every gases, okay, just give me a moment. Okay, so yeah, so gaseous particle dissolves in liquid. Okay, in class 9 you are going to learn about Henry's law. There you would be learning that what is the relation between the amount of gas and the dissolved amount of gas and all these things. Okay, so right now it is not important, but the thing is the gaseous particle dissolves in liquid to some extent. Okay, now this is known as dissolved oxygen. This is known as dissolved oxygen. This is the oxygen that is taken by the aquatic animals. Okay, aquatic animals. So they have these type of organs that can that can take the air from the water only. Okay, but we don't have that type of mechanism. For that reason we cannot take out the oxygen which is dissolved in water. Okay, so never try that. Okay, that the aquatic animals can do that. Don't think that you can do that as well. They have that type of mechanism inside their body. Okay, that's why they are very much interesting, and you are going to learn about them as well. Okay, now these aquatic animals takes that dissolves oxygen. Okay, now plants and animals depends on each other for exchange of oxygen and carbon dioxide from the air. From our very earlier knowledges, we know that the trees while they are while doing the photosynthesis, they gives up, okay, they gives up oxygen, isn't it? Okay, so what happens is what happens is during photosynthesis, okay, they just takes up water and carbon dioxide and all these things, okay, to make glucose, and they gives up oxygen in the air. So this is the source of oxygen in the air, and we are taking up that oxygen only to, complete our respiration process. Okay, respirations, via respirations we take up the oxygen, and that is the oxygen which helps us burn our food. Look, the food we take, okay, that is mostly in like carbohydrate form or sometimes of proteins and all, right? So we need to burn that thing. We need to burn our food inside our stomach. So we need to burn it. If you burn it, only then you would be getting some energy from it. Okay. If you burn something, think about it. We burn petrol, we burn diesel, we burn the coals, right? Everything we burn to take out the energy out of it. The same thing is, give me a moment. Yeah. So what happened is it's just fell down. Okay. Anyways, yeah, fine, I guess. Yeah, it's still working. Anyways, so the thing is, we were in like yeah, so the oxygen we take, that is helping us to burn. Oxygen we take, that is helping us to burn our food. And the burn, after burning the food, the energy we get from there, like the energy we get from the diesel, petrol and all these things, all these type of fuels after combustion, right? So the same thing is happening inside our stomach as well, inside our belly as well. So they are just burning the food, okay, and taking out the energy out of it. That energy is being used in our everyday life for our daily works, okay. So that is how we get the energy to do work, okay. Now we do the exactly opposite thing. So we take this oxygen, okay, by the animals. That is how the exact balance is maintained. That is why they call like they say that we should plant more and more trees, because as for our reproduction mechanism, what happens is like the amount of animals are getting increased day by day, right? So we need to keep that balance with the amount of animals and the amount of trees. So the amount of oxygen concentration, we need to keep that in mind, that we need to keep on planting trees, isn't it? Okay. Now let's watch this video to understand this part a little bit better. See? Just give me a moment. I think something's wrong. Yeah, so the problem has been resolved. Yes. Let's see. It would take a moment, I guess. So unless then we just keep on talking about all these things. Okay, once it's ready to get played, so I would just play it. Okay, so now the thing is about about the air, right? So we'd just keep on continuing after that if this starts playing, and we would just go through that video. Okay, for the time being, I'm just proceeding after that. So what happens is, so far we think we have learned. Yeah, so far I think we have learned that the air is a very important ingredient of the atmosphere, right? So in the atmosphere there are so many particles, so many different types of gases, like you may say, one may say like carbon dioxide, okay, like oxygen. There are so many gases like that, right? Like nitrogen, and they have a particular proportion that we have learned so far. Apart from that, what we learned, we have learned that the air is has a particular proportion of oxygen and nitrogen that is getting counterbalanced. We are taking that oxygen and leaving the carbon dioxide in the air. But similarly, the the trees and the plants and those type of things, they are just taking up that carbon dioxide and they are leaving the oxygen in the air. So that's how the balance is being maintained, right? After that, we have learned that the aquatic animals, they takes up the dissolved oxygen which is there in the water. Okay, that is all we have learned so far, right? Right now, something's wrong happening today. Okay, so as you can see that this boy has a windmill in his hand, right? Okay, so I think you can see where as he walks, the entire windmill starts, moving round and round. And this boy over here, he's just flying a kite. Now, why is it happening? Why is this windmill even, moving round and round? And why is this kite is getting is flying in the sky? So today's our objective is like today by the end of this session, according to that video, and by the end of this video, you are going to learn about the air, and you are going to learn about the different constituents of air and the properties and the uses of air, etc. So the thing is like around us there are the particles. Those are called the airs, right? So air is a mixture of different types of gases, and when it just starts flowing, we call it wind. Okay, now you cannot see air and we cannot smell it, but if you just turn on your fan, you'd be able to feel it. You'd be able to feel the breeze, right? You'd be able to feel the wind, like they're showing over here. So you can see like whenever you are standing outside, you can feel that there is some sort of breeze is coming, right? Some sort of air is flowing. We call it wind. Okay, and because of this wind, there are so many compass, like they just this is the things we use to understand the condition of our weather, isn't it? Yeah, we call it wind vines. So that was the thing, like a little bit of examples where we can see the air. Okay, not the sea, like we can feel or you can experience the presence of air, right? Now, yeah. So now, right now we are going to learn about the layers of atmosphere. So I think you can understand that there are the air and they are there in the atmosphere, and there is in the atmosphere there are so many layers. Okay, so we are going to learn about those layers, and as I told you, up to at 500 km above the Earth's surface, the atmosphere is there, right? Now, how is it helping us, and what are the different types of phases inside the atmosphere? We are going to learn in this video. And you can see, like over here, they are writing the atmosphere is comprised of layer based on temperature. Okay, these layers are troposphere, stratosphere, mesosphere, and thermosphere, and exosphere is also there, right? Now, if we just try to understand about troposphere, something is wrong today with the videos. I don't know what's happening. Anyways, I just keep on discussing about it. After that, I would just see to it. Okay, troposphere. So what is troposphere? Look, remember, just if this is the earth at earth's surface, okay, the first layer over your head of this atmosphere is called troposphere. It is just it is starting from the earth's surface up to 10 to 12 kilometers. Okay, so that is called the troposphere. Okay, 10 to 12 kilometers. So it is the place, this is the place where carbon dioxide, oxygen, nitrogen, all these type of gases are found. Clear? And this is where we can see the cloud. Okay, so this is all about short troposphere. And one more thing, if you just in troposphere, if you just go up, if this is troposphere, if you just go up, what would happen? The temperature, as you go up, the temperature would decrease. The temperature would decrease. For 1 kilometer rise, you would be able to see there would be a 6 degree centigrade decrease in the temperature. Okay, so that was about the idea. You can get the idea about the troposphere from here. Okay, the next is stratosphere. Now, what is the stratosphere? So stratosphere is up to 12 kilometers to 50 kilometers. Okay, so here you can see only oxygen, nitrogen, and ozone molecules are there in this sphere. Okay, and apart from that, here the if you just move up from the from 12 kilometers to 50 kilometers, when you're moving up, what happens is the temperature is also increasing. Now, why is that? In stratosphere, there is a layer, we call it ozonosphere. So the point is, in stratosphere, there is a place where the ozone gases are there. And in ozonosphere, the ozone gases are in they are just making a layer, and these ozone gases are the reason why the UV rays from the sun is not falling in the earth. So ozonosphere is a very important part of this atmosphere, and it just absorbs the UV and most of the heat okay, in ozonosphere. For that reason, it is absorbing most of the heats from the sun's surface coming from the sun, as it is just absorbing most of them. As a result, what happens is when you move up towards the ozone layer, so the ozone layer is in the top part of the stratosphere. When you're moving up, what happens is when you're coming closer to the ozonosphere, as a result, what happens is ozonosphere is a hot place because it is just absorbing most of the radiations like UV and IR and everything, and just it is just it is just absorbing most of the heats as well. So when you go up, you are going closer to the ozonosphere, and as you go closer to the ozonosphere, what happens is the temperature increases. Okay, by the meantime, just give me a break, and you just take a break of 2 minutes and let me see what are the technical problems that today we are facing. Okay, I'll just come back. You just take a 2 minutes break, and we'll just continue from this part only. Okay, so I think by now everything is okay. Let's see. Yeah, yeah. So here we are saying that the troposphere and the stratosphere, right? So troposphere is up to 10 to 12 kilometers, and stratosphere is up to 12 to 50 kilometers. Okay, and in there is ozonosphere as well. Now, after that, there comes mesosphere, right? After that, there comes mesosphere. Okay, so again in mesosphere, when you go there, what happens is again now look the uh, all the ozonosphere is now done. Okay, that is ended, right? After that, this mesosphere comes, right? Now, after this ozonosphere, this part is heated one. When you're moving up from the ozonosphere, now again the temperature started decreasing. Okay, this video has started playing, so we would just go through the video first. After that, but again continue with our explanations. So the sound is not playing, I guess. Need some time, I guess, again. Let's see. I think hope for the best, right? Something's wrong today. Yeah, that's okay. Fine. So let's see. So he's on in the is on space, right? And the blue ball over there, that is the Earth, right? Now you can see over here the layers. Those are the white layers after the blue balls. That is the atmosphere, right? So it is the troposphere, and here are the weather occurs, right? That is near about 10 to 12 kilometers. When you move up, the temperature decreases, as you can see. That is called altitude. So the height, you can call it altitude as well. Then we are trying to discuss about the stratosphere now. Now, again, you can see the temperature is rising when you're moving up, right? Here is the ozone there, as you can see, it is just harmful UV ray. It is just reflecting harmful UV rays and absorbing most of the heat, right? The stratosphere only, the airplane flies, right? So that is 12 to 50 kilometers. Okay. Now there comes mesosphere. So all the meteors, they burn upon entry. You can see that. Okay. After that comes thermosphere. It is in mesosphere only. After mesosphere only. So yeah, again, after mesosphere up to 500 kilometers. Okay. From meso to 500 kilometers. There comes the thermosphere. And from the name, I think you can understand the thermosphere is very hot. When you move up, it is getting hotter and hotter, right? So yeah, in thermosphere, if this is the thermosphere, then this part, the lower part of the thermosphere, is called the ionosphere. Here everything remains in ions. Okay, from ionosphere only all the radio waves are coming. So the radio waves, the telephonic waves, all the waves that is, they're in your mobile, they're in the radios and everything, they are just flowing through the ionosphere only. So ionosphere is there in the lower part of the thermosphere, right? So they are, all the atoms are ionized. They are all charged, right? And after that comes exosphere. Okay, so 500 to 700 kilometers, that is called exosphere. So here the thing is, like, the troposphere contains near about 75 to 80% of the mass of the atmosphere. So the troposphere only the troposphere contains 75 to 80% of the entire mass of the atmosphere. Okay. That is what they're trying to say. The ions in the ionosphere, so in the thermosphere there is ionosphere, and though the ions in the ionosphere, they are helping the transmit different types of waves. Okay. That's it. So I guess you have understood it. Okay, so the gases are like carbon dioxide, oxygen, and nitrogen. They are there in the troposphere. In the stratosphere, there are oxygen, nitrogen, and ozone, right? So that is the thing. Okay, I think I've understood it. Now we are going to discuss about the different properties of air. As we have already discussed about the air and how can we feel that, and how does it work, right? What are the different types of phases in the atmosphere? Right now we are going to discuss about the properties of air. So here you can see like what are the properties they're writing over here. First, in the air takes up some spaces. So just think about it. If you just take a bowl, okay, if you just take a bowl, okay, just like that, okay. I'm very bad at drawing, so bear with me. If I take a bowl like that, and if I just dissolve it, not dissolve it, if I just immerse it in a water, okay, upside down, then what would happen? So if I just do that, if I just push it down through the water, what would happen is, so the air that was there inside the bowl, it would be there, and for that reason, the water would not be able to go inside. Just try it in your home as well. But if you just tilt the bowl a little, the air goes out. Just wait for a moment. Yeah. So we just go through the activities first. After that, I would again describe it. That is the same thing they are trying to tell you. So if the bottle is being pressed inside the water is not enter the bottle even after pressing. When you just tilt it, then what would happen? The water would start filling into it, and the bubbles would come out. You just try it at your home as well. Yeah. So when the water is completely filled with water, when the bottle, there is no such air inside it. From there, you can say that air does not takes up some space. So when you're filling air in a cycle tube, what happens is, as the air takes up some space, so the cycle tube gets inflated, right? Right. Yeah. So the thing was like if you just immerse a bottle, okay, inside the water chamber, what would happen is there would be air inside the bottle. For that reason, water would not go in, okay, would not be able to go inside. As a result, if you just tilt that thing a little, what would happen is the air would go out and the water would get in, okay, and you would be able to see the bubbles are coming out. You just do that thing at your home with a mug or with a bottle. Both of them would work. So from there, we can say that air takes up some space. Apart from that, you have seen another part video, another example of that. If you just fill some air inside your cycle, what would happen is your tube would get inflated, right? From there as well, you can see that the air takes some space. Or you can just think about a balloon. When you just fill some air inside it, the balloon gets inflated, right? So from there, you can see that there are air inside it, which takes up some spaces, right? Now air has some mass. Okay. Now think about it. Like air, what is the constituent of air? So there are oxygen, there are nitrogens, there are water vapors, there are carbon dioxide, there are so many different gases like argon, neon, krypton, all these type of noble gases as well. Everything is there inside the air, okay, and they have a particular mass as well. So for that reason, what happens is the air also has some mass inside it, okay. Now you can understand this thing in another way as well, okay. The air has some mass. For that reason, it exerts some pressure in us, over us. So what happens is, like if this is you, air over your head is always exerting some pressure on you. What is the pressure? So the pressure is force applied in unit area. That is called pressure, right? So what happens is the air particles, so the different types of gas particles and different types of like dust and everything, those are there in the atmosphere. They are just exerting some sort of pressure over your head, okay, because of their masses only, right? So for that reason, you would be feeling a downward pull, okay, over your head. But if we are still not getting shrinked, because the liquids, the plasmas inside our body is, it is just exerting the equal and opposite amount of pressure towards in the opposite direction, right? So the plasmas and different cellular organs from our body, it is also exerting the equal and opposite amount of pressure. As a result, that is not any way harming us. Okay, got this? Now, air is affected by heat. So now think about it. If you just take some balloon, if you just take a balloon, and if you just heat this thing, what would happen? If you just heat this thing, what would happen? So we don't need to say what, I don't need to say what would happen. You already know it. If you just inflate a balloon and just put some heat on it, okay, what happens is this would definitely burst, right? Because the air inside this, the air particles inside this, okay, they are taking the heat. As they're taking the heat, they are getting higher kinetic energy. Look, heat is nothing but energy in different forms of energy. So when you are heating it, it is gaining the energy, and as a result, it is moving. It starts moving in different direction. Look how the air particles, how are they? How do they behave? Think about it. If you just lit up an incense stick, okay, on a corner of your home, what happens is you would be able to smell it even from here, right? So the air particles, so the gas particles, they can flow, right? They can flow to one place to other places, right? So that is the same thing happens. The air particles, they move, okay, or the gases particle, they can move. When you are heating it, what happens is the gases particle moves with faster velocity, with higher velocity, with higher energy. As a result, the balloon cannot take that velocity anymore. As a result, what happens is it's just bursts, right? So air is affected by heat. Another thing is air can be compressed. So air is consisting of gas particles, right? Now think about it. The gas particles are the most compressible, the most compressible. So where have you seen this? You have definitely seen this in the cylinder that comes in your house, right? The LPG cylinder. Give me a moment. Yeah. So the LPG cylinder inside your house. So the LPG cylinder is also consisting so many different types of gases inside it. Okay. So LPG contains butane gas and propane gas and ethane gas. So many gases are there. Ethyl mercaptan. So there are so many gases inside the LPG. But still you can see like an immense amount of gases that is, getting used for a month's cooking. Okay. More than a month. So that amount of gas is compressed in that single cylinder that is so small, isn't it? So now think about it. So the gas can be compressed into a very small place. Okay. And it is so compressible. For that reason only, you can see like after like there are so many, like there are perfumes, right? Perfumes, when you just take them, you can see that you just use the perfumes for months. Okay. So the perfumes are nothing but the gases, right? So we can also say that is an emulsion, that is a sol. But yeah, for if we just forget about that, that's the main thing and main ingredient inside it is gas. Okay. So for that reason is we can say like the gases are very much compressible, right? And air is affected by the altitude. I think what is the effect of different altitude on the air, we have already learned it, isn't it? So these are the main properties of air. Those are there, right? Now, is playing. Okay, it's done. Now, the composition of air. So what is the composition of air? So think about it. Like as I told you earlier as well, so there are so many things inside the air. So the first thing is nitrogen, oxygen, different types of noble gases, carbon dioxide, etc. are there. But there's a particular amount, the particular amount of these gases are present in the air. So what is the proper amount? As you can see, the nitrogen is present up to 78%. Yes, you got it right. So the nitrogens are the most abundant gases inside the air, the most abundant gases inside the air. So you can see that it's a mixture of different gases, and the air in the earth atmosphere is made up of approximately 78% of nitrogen. Okay, and what else you can see, the second most important thing is oxygen, a major constituent, 21%. You can see 21% of oxygen. Air also has small amounts of lots of other gases. So inside air there are some other gases as well, like carbon dioxide, that is of 0.03%. And we can say the noble gases, that is there up to 0.93%. Okay, where in this 0.93%, 0.9% is argon, and rest of the 0.03%, okay, that is the other, like neon, krypton, xenon, and everything else. Okay, so these are the main ingredients and the amounts in which they are present inside the air. Okay, now what are the uses of air? Okay, now what are the uses of air? So definitely I don't think like I have to tell you what is the uses of air, right? Important uses of air is sustain lives and growths. So as I told you, air contains oxygen, isn't it? Now when we eat something, let's consider we are eating some glucose in the form of some glucose. So it is just reacting with the oxygen from the air. Okay, so this video has got started, so we just go through the video first. After that I would just explain everything again. Okay, so moving airs are known as wind, right? I told you earlier. So it helps the sailboats and the gliders to move. It helps the windmills to move. From there, you can generate the energy, right? So there are so many uses. They are just showing you some of them. Like what are the everyday uses that we use as a like for the wind? So they are used in different purposes. You can see the purposes, but the main thing is how does it help us in the life and the growth of our body? So C6H12, this is the glucose. When you just burn it inside your belly, what happens is it gives us CO2 plus H2O plus an immense amount of energy in kilocalorie. Okay, immense amount of energy. That is the energy. Or you can say adenosine triphosphate or diphosphate. You would read about it. So all these things are giving us the energy to do several different types of works. Okay. Now that is the thing first. So this one is glucose. Okay. And this is being burned. The oxygen is coming here from the respiration only. Second is combustion. As I have already shown you, and I am going to show you again another process of combustion. So what happens is in combustion, if we just burn something, like let's take an example, like if you just burn magnesium, it gives you magnesium oxide, isn't it? It gives you magnesium oxide. So this process is known as combustion reaction. Combustion reaction is nothing but burning of something. Okay, as you have seen, like heard about combustible substances, like those the substances, those can be burned. Okay. Apart from that, to maintain temperature, okay, without the vents, the temperature of the earth would be very high, would have been very high. Supply of energy, as I have told you, in windmills, we use this wind only to generate the energy, the non-renewable sources of energy. So these energies are very much useful for us. Okay. and these type of energies do not get exhausted. So for that reason we call it non-exhaustible as well. Okay. Another thing is photosynthesis. So as I told you, like in air there is carbon dioxide. This carbon dioxide is taken by the chlorophyll, and apart from that this water full of vitamins. So they both react to give you C6H12O6, which is the glucose coming from the coming from the ground and coming from the different types of plants. Okay. And oxygen, this is the oxygen that is given out for animals use. Okay. So this was about it, about the uses of air. Now I think you have got the entire chapter. Now I think you have got the topic I have told you. There is another video on this, and we are going to watch that video as well. So I think you have understood all of it, and I think there is no such doubts that you have so far. If you have any doubts, then definitely don't forget to reach out to us via the forum, and you can ask the question in the forum. Okay. So please, if you have any doubts, you can just write it on the forum. Okay. So that's it for today. I guess we are going to meet each other soon. And I had a lovely time with you. And take care and keep on learning from Ask IITians. Bye everyone.